Right, so in this video, what we want to look at is variation. There are two types of variation that we're looking at. One is the direct variation. And with a direct variation, it looks like this. Let us say y varies directly as x. So let us say y varies directly as x. What it really means is y, and this is the variation symbol, it varies directly, so as x. So if y varies directly as x, this is what it really looks like. However, if I'm going to replace the variation symbol here with an equal sign, for example, y is equal to, then there is going to have to be what we call the constant of variation that has to be a part of the whole thing. So I'm going to use k as my constant of variation. Now you may be asking, what is this k? K is a value that will remain the same throughout this question. So with variation, especially say this direct variation, there are times when the value for y will go up. Because it's direct variation, the value for x will go up. But the value for k, which is the constant of variation, will remain the same. There are other times when the value for y goes down because it's a direct variation. The value for the variable x will go down as well. But the value for k still remain whatever it was. So it stabilized the variation and it is always there. So basically, when we're doing a variation, we'll normally get variable 1. That's the first variable. It's always going to be to the left, like the y. And the next condition, which is our second variable, it's always going to be on the other side of the equation. So it's going to be y, which is the first one, is equal to the constant times the second variable. So let us take a look at what a question looks like. Okay, and it says here that if m varies directly as v squared, when m is 2, v was 3, we want to calculate the value of m when v is 6. All right, no problem. Now, first and foremost, before we can do any variation question, we want to identify what type of variation. You could see directly coming out, right? So we know we're dealing with a direct variation. This is my first variable, okay? And this is my second variable. So what I'm going to do is I'm going to say, okay, m, so I'm writing the equation that links these together, So it's m is equal to, I'm using k for my constant of variation. So m is equal to k v squared. So we could read, if m varies directly as v squared, I'm going to write m equal to k v squared. K is always there, okay? The question can't work out without k. The key thing is, in order for you to solve any problem, you definitely need to find a value for k. We do not get a value for k, and most times you have to find it. So take a look. I'm going to have to use a situation with m and v that we got. So whenever we're doing variation, we will always get a condition for the two variables that occurred already. So this says to us that, hey, when m was 2, v was 3. It happened together already. So we could use that to find k. Let's take a look. Remember, m is equal to k v squared. It is said that when m is 2, I'm going to substitute 2 for m. So 2 is equal to k. We don't know k, v squared. V is 3 squared. Take a look. I substitute 2 for m and 3 for v. Now I can find my constant of variation k. So 2 is equal to k times 9. Now, in order to find k, I'll divide both sides by 9. So we could see here that k is equal to 2/9. Now, because I know what k is, I'm now able to solve a problem, okay, that involves a missing m and a value for v. So this is what we want to find now. We want to find a value for m when v reaches 6. But remember that k is a constant of variation. So what this means is even when m and v are changing, k is a constant. It's going to remain the same. Now let us use the formula, and there is one formula for this question, and it is m is equal to kv squared. This time we're trying to find m, but we know what k is. K is our constant. It's 2/9, and we're going to multiply this by v squared, which is 6 squared. Let's rewrite this. So 2/9 times 36/1. And at this time, 9 could go into itself 1, and 9 into 36, 4. So basically, we're getting 8. So m is equal to 8. So this is how we solve these problems. The conclusion is we're going to have a pair of the variables. So we're going to get a m, get a v that works. We use that to find our constant of variation. And then from that, we use the constant and the other variable to find the missing one. It's always going to be of that format. Let's take a look on another question. All right. All right. So in this question, it says, given that q varies directly as p, using the values of p and q in the table, calculate the values of a and b. Let's deal with this. So again, what we want to do is to write the formula that will actually control this question. So let's read, given that q, so q is my first variable, it varies directly, so I'm dealing with direct variation as p. So this one, the formula or the equation that associate q and p will say the first variable was q, so it says q is equal to kp always. So until this question is finished, we will be saying q is equal to kp. What is k? The constant. We never normally get it, so we're going to have to go in search of it. For every variation question, they're going to give you a pair, meaning we're going to get a value for p and a value for q that already worked. For example, if we look in this column here, so p values are in that row, q values are in this row. So take a look. When q was 6.1, p was 2. We have those two values. Let's write them down. We got that p is 2, q is 6.1. You could see that in that table. But we do not know what k is. So the intention is that we need to find k, the constant of proportion, very early so that we can use it to find a and b. So we are now in search of k. Now, remember, we're going to substitute in the formula q is equal to kp. So wherever we see q, we're going to put 6.1. And that is equal to k. We do not know what that is, but p is equal to 2. So we just substituted 2 for p and 6.1 for q. At this moment, what we want to do to find k is we're going to divide throughout by 2. So 3.05 is equal to K. So now that I know what K is here, now that I know what K is, I am now able to work on B, work on A. Okay? So let us say I want to work on A first. Let's take a look. So I'm going to put it right here. Now, if I'm going to work on A, let's write what we have in that situation. Now, bear in mind that we're dealing with this now. A is a p-value, so I could write this for us. A is actually a p-value that we don't know. What I'm saying is A is in the P row. It's in the row for P, as you could see. So it's a p-value. We don't know it. The Q value that is associated with A is actually 1.2. What is K? K is a constant. I just found it. It's 3.05. What I'm saying is that K will remain the same throughout this question. P and Q will be changing, and that's fine. Remember, we're in search of A, which is a p-value. Let's write back the formula that will dictate the pace for the question. So it says Q is equal to KP. Q is 1.2, and this is equal to K. We know that it's 3.05 times P. But remember, P is some A value that we don't know, right? So I just replace the P, I put A for it because I'm trying to find the letter A for that. So let us see now. Basically what I'm saying, this spot is a blank spot. In order to ask me for the p-value, they label it as A. That's all right. Now, A is simply to divide here. So we're going to divide. So we're going to divide both sides by 3.01. 3.05. So what we have here is 1.2, and I'm going to divide that by 3.05. And I'm going to get 0.39, or we could say 0.4 to 1 decimal place. So this is equal to A. So my A value is 0.4. So that is my A value there. Now, let's take a look on finding the B value. If we're going to find the B value, we're going to go where the B value is. It's in the column. It's a Q value, right? So we're looking for Q. It is labeled as B. And we have a P value, which is 8. So watch this. P is equal to 8. That B value is a Q that we don't know yet. What is K? K remains the same. It's 3.05. Now remember, the constant of proportion, K, is actually the key throughout. So let's write back the formula. It's Q, which is equal to KP. Q is actually a B value that we don't know yet. This is equal to K, which is 3.05 times P, and P is 8. So basically, I'm able to find my B value, which is a Q value still, same thing. So 3.05 times 8, and we're done. And I'm getting that B is some 24.4, and we're done. So basically, this is how we handle a direct variation question. Now we're going to take a quick look on the inverse variation question. So let us just take a quick dive into the idea. Now, if I'm looking at an inverse variation for any inverse variation, let us say there is something that says y varies inversely, or it is inversely proportional as x. If y varies inversely as x, it's really this: y varies inversely as x. So this is the variation symbol that deals with proportional. It's proportional. It's inversely proportional to it. So if I'm going to replace that proportional symbol with an equal sign, then I have to bring in the constant of variation. I'm calling it k, and it's going to be multiplied by not x, but the inverse, and that is why the inverse comes in. So in the end, it's going to end up that the k is on top of the second variable, because the inverse means 1 over the second variable, so it becomes a denominator all the time. So when we're doing the inverse variation, the second variable will actually be in the denominator every time. So let us take a look at a question. So this question says, given that y varies inversely as x squared, and that y equal to 3 when x equal 2, calculate the value of y when x equal 3. Now, this is what we're saying. Let us first write the equation that dominates this question. So it says, given that y, this is my first variable, varies inversely, so I'm doing inverse variation as x squared. Let's write the formula, the equation that associate these two things. So we're going to say y is equal to k over the second variable. Remember, we did say that because it's an inverse variation, the second variable will be a denominator. Now, this is the equation that will drive this question. But there is one thing here that we have to get out the way first. We need to know the value of k, because we can't work without it. Now, let us write down what we do know. We do know that when y was equal to 3, x was equal to 2. The value of k that made that occurred, we don't know. Now, let us substitute these values for x and y to find k. Let's take a look. So I'm going to rewrite this. Y is equal to k over x squared. So y is 3, so 3 is equal to k over x squared. X is 2 squared. 3 is equal to k over 4. Now let us multiply both sides by 4, because my intention is to get k on the right side. The 4's cancel, so 12 is equal to k. Now, because I know what k is, I am now able to find anything in this question. So let us take a look. Remember now that k is equal to 12. If we read the question, it says calculate the value of y. We do not know y in this case. When x becomes 3. So now x is equal to 3. So let us utilize that the same formula, right? Because this formula dominates this question. It says y is equal to k over x squared. We are in search of y. It's equal to k, which is 12, over x, which is 3 squared. So this becomes 12 over 9. 12 over 9, if we break this down by using 3, we'll get 4 over 3. So it means that y is equal to 4 over 3. And that's the answer for that question. Now, what we're going to do is we're going to take a look at another question. Let's go. Y varies inversely as X. Now, let's write the formula for this. It says Y varies inversely. That means the second variable comes at the bottom. We are going to have to utilize what we know to solve these problems. For example, this is the column that we know the details for. So X is equal to 2 when Y is equal to 8. K is the constant of variation that we do not know as yet. We're going to substitute 2 for X and 8 for Y in this same equation here. So let us do it. Y, which is 8, is equal to K, we don't know, over X. What we're going to do is we're going to multiply both sides by 2. So 16 is equal to K. So here it is that we know that K is 16. Having known that K is 16, we are able to use this. K is equal to 16. And our intention is to find A. Remember, A is in the Y row, so it's a Y value. So we could say A is a Y value that we are trying to find. Look in this column here, you realize that 32 goes with it. 32 is an A value, so it's an X value. So X is actually equal to 32. So when Y becomes A, X is 32. We're in search of Y. So let's write the formula. Y is equal to K over X. I'm going to replace the Y with A because we saw that we're in search of the letter A, which is a Y value. So I'm going to put it right here. So A is equal to K, which is 16 over X, which is 32. At this time, we realized that 16 could cancel in itself and 32. So 16 into itself is 1. 16 into 32 is 2. So what we do have is that A is equal to 1/2. And we're done.